All right, good evening. So let me start. Um, Pallavi, are the slides visible?
Yes, sir.
Okay, great. All right, so started with perception. I mean, we started with sensation technically. And if you remember in the last class, we stopped at illusions, which is where our mind gets tricked. And I was saying that there's difference between uh, what is there in the world versus what you see. So this is where we stop. This is the Muller-Lyer illusion, where essentially these are of the same distance, but it seems that this line on the top is is longer than this line at the bottom. But actually, if you look at it, they are of the same distance, or they are of the same length. So if you draw a line, we are confident, but without the line, when you look at it, it seems that this one is longer than the other. And the explanation for that is because of the fangs here. So depending on whether they are inward looking or outward looking, it it makes it feel, so it's not real, right? So it makes it feel that this line is longer. This is also another example to show that our perception is many a times driven by the surrounding context, and here the surrounding context is these two fangs, but it can be many other things. To explain this point further, I have an activity here that well, first you do this, and then we'll talk about the theory behind it. So these are the plans of huts. Okay, so these are plans of huts, and what you see is on A, all these smaller dots that you see, these are the holes. All right, and this is a site of an archaeological dig, so which means that people have dug up the ground, and as happens in archaeology, you figured out that probably if the huts were made out of, let's say, wood, then you would have to have these, you have to dig the soil and put certain pillars, right, to make up your hut. So what you see here are different patterns of where the pillars were. Okay, so these are the patterns of holes that you see, which is in figure A. The question is, as an engineer or an archaeologist, how do you figure out what might be, not is, okay, what might be, how the huts might have been looking like? So one possibility is shown in figure B, where if you join the dots this way, then probably the hut was more of a rectangle, and this is the entrance to the hut. You have another possibility of point C, where probably there are two different structures. One was a rectangular structure like this, and one was a circular structure like this. What this rectangle did or what this circle did, we don't know, but we are currently just looking at what could be the potential structures that explain the dots that we see, which are essentially holes that are there in this archaeological dig. So my question number one is, how do you think our mind are able to connect the dots? If you remember, we also used to play this connect the dots game when we were young. So there would be different dots, and children are asked to connect the dots and eventually come to a figure. This is pretty much exactly what is happening here, but here this is not a game. This is more of an engineering or archaeological problem to solve. But the basic working of the mind remains similar. So first question is, how do you think that we are able to connect these dots to come up to a shape when it does not exist? And second is, what additional knowledge or learnings might be biasing whether we go for B or we go for C as the options? But even before that, I just want to take a quick vote. And which one do you think seems to be the more probable drawing? Is it B or is it C? Based on A is what you have as evidence, you are having B as one potential model and C as another potential model. Which of this do you think is more probable as a model? So if you think it's B, you type in B in your chat. If you think it's C, you type in C in your chat. Okay. Um, All right, so we have enough number of responses. Yes, it's the correct meeting, Vivu. All right, so we have enough responses. Thanks, everybody. So it seems that B is more likely among your group, but there are many people who say C also. I mean, just by doing a eyeball analysis, it seems maybe it's about 70-30 or 65-35% of differences, but B seems to be more frequency wise compared to C. All right, so first question is what I initially asked: how do you think our mind is able to come up with these kinds of these kinds of activities in which we connect the dots? Second question was, what kinds of previous and past knowledge or learning and etc. might be biasing our results? These two questions, if you ask, then we'll go to figuring out why do most people feel it's B, and why do the people who say C think it's C? All right, so let's go one by one. Who wants to go for the first question? And raise your hand. If there are more than one, then we will try to hear a couple of your answers. Yes, Nishant, go ahead.
So I believe that it's due to our previous conceptions of how houses look. So they are mostly in a rectangular shape. So
No, first
naturally,
question. No, so you have jumped ahead a little bit.
oh,
Sorry. So the
sorry.
first question is, how do our minds at all are able to connect these kinds of dots? This is a perception question.
I think it's. I think the answer is quite similar because we have some preconceptions, and then we are trying to connect those dots to just fit those concepts, and that's how we come up with a rectangular shape like this one.
Okay. So if you think about it, this is why I just love the way we work, and I'm sure some of you might be excited about it too. If you think about it, really there are no lines, right? So basically they are dots. Our mind somehow tries to group them together, and that's why you are able to draw a line. This is almost similar to when you do curve fitting in mathematics. You have a whole bunch of lines and you want to see what is the curve that most likely is going through the maximum number of dots. And that's the idea. But in the mind, it's very interesting. So also, it's interesting in mathematics, but in here, it's interesting because there is actually no line. And sometimes, like what you see in B, actually you see there's hardly any dots towards the later side of the figure. There are just 3 dots or 4 dots, and there's a large line that connects the 2 dots. Whereas there are much more lines here, much more dots here, but there is no line drawn, at least in B. Right? So you're right, Nishant, but that's from where I was coming. And let's think about it. I mean, it's not trivial at how we are able to do something like this. And there are theories people have given about it. I will go to it later, but I think more importantly, we learn by examples. At least I like applications and examples more and theory less. So that's why we will always have examples put forth, and then the theory will follow behind it. Any other people to add to something? Yes, Ashish.
Sir, I think like the dots which have minimum distance between them are mine to try to match all those dots such that no dots is left. And also the figure should be something symmetrical because we have two options. And here in the second option in C, the figure is not more symmetrical than the B. So our mind thinks that it is more symmetrical, and the dot distance is also minimum, and also it covers almost all the dots. So that's the reason.
Great.
Yes, sir.
Two wonderful points. So now either either you can try or somebody else can try to figure out whether first of all, why is it the case that we like or we prefer uh, symmetry, or also prefer less noise? So when you want to run a line between maximum number of dots, you are essentially reducing noise. So what is it that helps or pushes us to do that? Abhishek, yeah, you want to add something to Ashish?
Hello.
Yes,
Hello.
go. I can hear you.
Sir, maybe there's also a thing that we are told that these were huts. So
Mhm.
our mind tries to form a similar structure which resembles a hut. If we were given the same dots and told that, let's say it was a pond, then um, we would have made a more of a circular kind of pattern, not the rectangular one. So maybe that's also the thing. What it is, what we are told, the mind also interprets in that way.
Yeah. Yes. Wonderful. So, I mean, there's a whole field of psychology. In fact, um, many of them were philosophers who are called Gestalt psychologists. Gestalt, Gestalt. So, what they did was they came up with some principles of perception, and they try to find what are the mathematically regular. So it's not like, again, to go back to my previous discussion and one or two opening lectures, all of psychology cannot be subjective. You cannot say it's my will or it's my wish, that's why this is how I perceive it. Well, you can do it, you cannot ever build a science out of it, right? So these Gestalt psychologists wanted to build a science, or more of a scientific inquiry about perception. So if you are able, or if you want to build science, the first thing, not the first thing, that a very important thing that is required is to come up with rules. And rules are something which are supposed to work across contexts or across people or across cultures, right? So on one side, there was this very large interest in trying to find what are the fundamental rules that is true across the world for all human beings, at least human beings. I mean, it could also be true for other species, but we want at least to have rules for that is true for all human beings. So Gestalt psychologists try to come up with that, but they didn't call it rules, they called it principles, because rules have a slightly different connotation, that they have to be true under all circumstances. Principles, rather, are standard statements which are true under most circumstances. But it is still has enough space for context because of the many things, including, what some of you were saying, that we could have previous prejudices, we can have previous knowledge, we can have hypotheses that this is how hearts look like. So all of that will also feed into how I perceive these dots, right? So that's why Gestalt psychologists call them principles of, or it's sometimes called principles of Gestalt psychology. And one of that, very important one, is symmetry. Our perceptual systems always look for symmetry. We just love symmetry. In fact, there's work in aesthetics or in architecture or art which says that a symmetric drawing or a symmetric architecture is perceived to be more beautiful, or people prefer it more, or they buy it more or like it more. As somebody was saying, for B, it's symmetry. The symmetry is a principle of how perception works. If there is no symmetry, we want to build symmetry to it. So symmetry is, is fundamental to thinking. The second thing is about closeness. The dots which are close by is what we are connecting, but we are not really measuring the distance about them, right? So automatically, or somewhat automatically, our perceptual systems are also drawn to stimuli which are close to each other and see as if they are of the same part. So if you have three dots but they are close to each other, you will try to draw a line between those three dots. But if there are three dots again which are far away from each other, you will not like to draw a line between those three dots. That shows that if something is close by or placed close by, we think they are part of the same thing. That's why we want to draw a line between the three dots, which are closely placed compared to the three dots which are spaced away. All right. So, and there are a couple of other principles which I will explain in the next class. But this is one idea, and see how a problem that actually happens in archaeology tells something about how the mind operates or how perception operates, or knowing how perception operates can help you predict how an archaeologist or an engineer is going to perceive or make sense out of this drawing, or this kind of a map. So that's how we I personally think is the application, or one leg into the real things that are there in society, or that are really problematic or interesting to society, is something that we should talk about. And this is one such example from the domain of perception. The second thing to understand is there are this continuous tug of war, as I was saying, between we want to find common processing principles across all humans, but we also realize that there are individual differences in the way you are going to perceive it, which is why you have a common processing which perhaps explains some things around B, but individual differences which also say why a lot of people also say it's C. All right. So now let's hear from a couple of you. Why do you think that C, for those who were saying C, why do you think that C is more possible? And you already heard why some of you were saying B is more possible. And let's have a dialogue about it live. Like you all can just raise your hands and talk against or for or in response to each other, and I will intervene in between. In the process, we'll try to understand how perception actually works out using this archaeological dig example. Clear? Okay, so who do we have? Yes, Akash.
Sir, as soon as I looked at the picture A that has been provided, the leftmost upper corner, there I observed a right angle. So I tried to join those first because I was finding the dots very closer, and it actually forms a corner of a square shape. So I prefer to make a square there first. Then I saw something circular there, and from my previous knowledge of mythological stories, I had also seen in stories that there used to be circular huts, so I chose for the two structures, a square one that was smaller in size and a circular one also.
But these are two huts instead of one.
Yes, sir. So there could be two huts. One might be used for cattle and keeping cattle and storage of food, and other might be used for living. That could be a possible reason I found.
Yeah, I mean, it's not just it's interesting, and I think you have a very valid way of thinking about it. And but it's not just mythology, by the way. Circular huts exist in many tribal areas, including areas in India, in Andamans. We have seen, and you can see in Port Blair, there are examples of tribal huts built by native people from Andaman. The circular huts is also common in Indonesia and also in Africa. So circular huts still are heavily built by a lot of people. Yeah, anybody who wants to add to what Akash was saying or counter something or any of such stuff?
Hello, sir. Am I audible?
Yes, Vaishali.
Sir, I chose B. Reason being, whenever we are asked to join two or more dots, the first thing that comes in our mind is a straight line to join them.
Mhm.
And also, like, if we do not know what shape we are going to get, we try joining them through straight lines and join the maximum possible as said. So I chose B because of that.
Yeah, but so straight lines you would also get in C. You have basically two kinds of structures that you can make out of C.
Yeah, but as said now, like maximum, we want to join maximum number of dots. So I preferred like straight lines, which could be used to join maximum number of dots. So I got B as an answer. In the C, there was a curved path between like a lot of dots creating the circle. So that's why.
I see.
And
Okay.
some at some places the dots are quite far away, na, so we have to make that curved path. So that is something that I couldn't like sink in at the first go.
Hmm. Yeah, makes sense. Which also again mentions about this principle. So there's a third principle. I'm ending up seeing all the principles in this class. There's a third principle called proximity. So whatever is closer to each other, proximity is closeness. Whatever is closer to each other, we think of that as part of the whole. So that's why we would also want to have or kind of group dots which are closer to each other in the same line or whichever curve you draw. But proximity is another basic principle in Gestalt psychology which says that that's how our perceptual systems are biased towards picking things which are proximal to each other and think that they are part of that figure. So this is interesting. So Deepika Meena, right? So I don't know if everybody can see, you have IIT in your profile picture, but this IIT, of course, is made up of different things, and this is a classic example of perceptual organization, by the way, where different kinds of stuff you bring together, and it becomes part of the I, or it becomes part of the T, and actually there is nothing between I and T, but still we read it as IIT. We don't read it as I and T. This is another live example I just saw because it's right in front of my eye. That this is another great example. So every time you enter the main building again, opposite to the design department, you see the IIT that students have come out with a lot of junk and stuff. That should remind you about how cool perceptual organization is, because we are seeing it as part of the group, or part of one single I, or part of one I as part of IIT. But really there is space in between, or there is nothing. But this is what, this is another example of perceptual grouping that we are talking about, which can be explained by Gestalt psychology. Okay, we have a couple of hands coming up. Rishi and then Solaz.
So, so I feel C is the appropriate one because while looking at the three diagrams, while we see the second one, we got these. Of course, they are holes, they say, but while looking at the diagram in B, there are so much holes which are not connected. Means which doesn't show any sense. And I can means while in C, while looking at C, we can say that most of the dots are connected, and it makes some sense because our fellow classmate said one could be used for living. And while looking at C, we can see that circular hut has a entrance also, so that could be means the of course the entrances should be somewhat some strong kind of entrances, so they gave some big holes kind of thing. They could have used some bigger woods. And the second hut, the rectangular hut, could be used as some shed or something, which could be used for some storing and for cattle purposes. And the other remaining holes could have been like some fence, like the bottom ones, means bottom for the things. So this made some proper sense because so much of holes are connected, and something inside the huts could have been some specific rooms or kind of thing. So if we see as the appropriate one.
Okay, this is a very important point. And this also shows how we are getting more and more deeper into this issue of perceptual processing. In fact, if you read the book, this is from Robert Salso's introduction. What does he call it? Cognitive Psychology is the name of the book. Uh, this, Rishi, what you just mentioned, is indeed one important facet that archaeologists do consider. I mean, it's a little crazy to think that people have done things without any reason to do it, right? Unless you're just, I don't know why you would do it. So the more you explain by possible droughts, the better is the explainable power, which is exactly what you ended up doing. So great answer. Solas, yeah.
Yeah, so right now it was Solas, now I'm Rishi, I'm speaking.
Oh, I'm sorry.
Yeah, it's fine. So actually what I did was my approach was a little different. Instead of focusing on the dots, what the first thing that I saw was the empty big white rectangular space. So instead of the dots, what I saw was the biggest empty region with a coherent, with a uh, certain amount of shape around it, well defined. So based on looking at the empty space, I saw that B is most obvious one in this case, because in C even though there is shape, there is a lot of in the suppose the smaller rectangle in C, there are a lot of dots still inside the structure, whereas in B, compared to the size of the rectangle, the number of dots inside the structure are relatively less.
Yeah, that's another great point. So now think about it. We have two very, overall, I'm saying across all the people, and all were great points, by the way, I must say. But still, we have this contention, and both parties are making good arguments between B and C. Now, you as a third party, let's say, let's look at what potentially might be more possible or more probable. And to be able to do that, what additional stuff do I need to know about this culture or this village or this country for me to be able to take a side between B and C? That is the second point about previous hypothesis and also prejudices, but prejudices we have not gone into, but previous hypotheses. What are the other kinds of hypotheses you can build around based on some past knowledge about these cultures or these villages or villagers who had built these huts? What if we know something that we will be able to weigh in between B or C? What could that be? It's already there in a couple of things that you all yourself said. The answers are hidden there. Already stuff people have talked about. Or maybe there are new ones, but it's already there in a couple of previous answers. So we need to know something about these people to be able to choose between B and C. Yeah.
May I speak?
Akash, yeah. Yes, Akash.
Yes, sir. Sir, we could have looked the previous climatic conditions that would have prevailed at that time and have chosen for suitable structures for living, such as the round structures might be good at a proper habitation, like they could have been given, they would have been successful at providing a lower temperature for living, or the round structures are good at means they are less distracted by the winds, or such conditions would have been taken into account. Other thing, their living habits, like do they keep cattle or something else with along with them, or they prefer for farming, so they have to keep the produce with them, so they would have chosen the C structure, or such things could be taken into account.
Yeah, very true. In fact, we do know that to a reasonable extent about different climatic conditions is slightly more easier to understand or to predict or to know rather compared to ways of living. But yes, that's one way to do it. There's another thing which is again hidden in a couple of things, which is about prejudices. So what kinds of prejudices did we bring forth in this table in trying to answer this question? You know what's the prejudice? Yes or no? You can, some of you can say. So prejudice essentially is, yeah.
It is like an opinion which we have before we, which is not based on any experience or reason. It's a preconceived opinion.
Oh, so yes, it's an opinion which may or may not reflect the reality, but it also may or may not be dependent on your experience. So sometimes prejudices are formed because of an experience, but we wrongly generalize it. So, for example, we might go and have a bad experience in a foreign country, and we say, "Oh, everybody in that country is bad." And that's one way to think about prejudice. Sometimes we don't even have that experience, but still we think that everybody in this country is bad because of other things. So actually there's very little that we are able to conclude or we are able to know without experience. But prejudice essentially also highlights that it may not reflect what the real thing is like. So that's the overall meaning. So the question is, what kinds of prejudices have we brought to this table to answer this question?
The hut has to be a regular shape.
Any
Sir,
hands up? Okay. Purvi, you want to go? Yeah, there's nobody else. So you go ahead. Yes.
sir, we have assumed that these are the plans of huts. Like it might not be true that these shapes are of huts. Maybe they are some other buildings, or maybe it's just like a fountain or something.
No, that's true. That's you're right. But here it says they are plans of huts. So let's say, for the time being, let them be huts. But even if they're huts, what are the things that we are assuming about them in the discussion till now, which could be like a prejudice? Rishi
I think we have assumed here that the huts have to be regular shape.
and Solas both. Go ahead, one of you.
Yes, sir. I'm audible, right?
Sorry, I can't hear anything. Okay, Solas, do you want to try? I couldn't hear Rishi.
So, the kind of prejudice I want to insert is like, in my village or in my surroundings, while I was a child, most of my surroundings will have huts like around a ship, around a like a circle like huts will be there, and most of the cattle's and sheep's or goats will be in a place like a rectangular sized hut or something. So
Mhm.
that made me think like, means of course, means obviously this could be some circular hut, that could be some rectangular shed for some animals, and that made me think like that. So
Yeah, fantastic. So this is part of past knowledge. It's not, I would not call this as a prejudice, because you have valid reasons um, to use your previous experience or past knowledge and apply that to the current problem that you're solving. Right. So yeah, but this is part of past. So we know that perceptions are influenced by past knowledge, sorry, previous hypothesis, and the other thing is prejudice. So let's see if there's some other thing in there. Yes, Tanya and then Ananya.
So I feel that it should have a door opening. So that's why at least one figure should have a door opening. So in the B part, it shows only one heart with the door opening. So I feel that that's more probable. That's why I was inclined to B. And a
Mhm.
kind of prejudice that it must have a door opening which we have in usual. Maybe there's no particular door in that heart and it's just an open wall or something.
Yeah, you're right. I mean, I don't know that. Have you, if any of you have visited a town or village in Maharashtra where none of the doors have huts? It's near.
None of the doors have huts.
So, I'm so sorry. Yeah, this happens towards the end of the day. None of the, not huts really, none of the houses have doors. And most of those houses are pakka houses. It's not kacha ones. Kacha pakka in the form of civil engineering kind of thing. So these are all made of brick, but they don't have closed doors. They have openings to move in and out, obviously, but they don't have the doors. There are also, Tanya is right, there are also a couple of constructions where they don't have a closed door, but still, it's still not such a big, I would not call it as a big prejudice, because ergonomically or engineering wise, it makes sense to have doors. And it also makes sense to close them for multiple reasons. Right. So I was trying to point at something else, which I could after a while. Let's just hear Ananya and then we'll move on. Yes, Ananya.
Yeah, I think the assumption that we made that the huts are basically for villagers. Like we
Yeah.
thought something about cattle or villagers living in, but it might be possible that these huts are being made as resorts. Like
Mm-hmm.
this, they can be made as resorts for people to experience. The city people to experience how the life in the villages can be, and involving cattle and all that. That was a assumption that we made.
Yeah.
I
Yes. Yes. Good. So there is a. I mean, this is a kind of an implicit assumption that we make when we go about doing perception of many things. And there is a website at the Harvard University's as part of Harvard University called the Implicit Association Test. I don't know if Dr. Yashpal is going to cover that, but any of you can anytime go and take the test yourself, and it will tell you whether you have certain stereotypes or certain biases, implicit biases or implicit stereotypes in you about different kinds of things, from gender to work and moral stuff and related things. Yeah, so I also had the same opinion that, let's say you have the square and the circle. Why do we have to think of cattle? um, what about this to be used like a sitting room, for example? So somehow this idea of huts automatically primes. This is also called the idea of priming in social psychology, or even cognitive psychology, where one word makes you remind of certain related concepts, and your hut somehow got related to village, and village got related to cattle, which is quite likely but need not be. That's a classic example of. Now you see, and this is what I was telling you in the last class, that every time we talk about perception, many a times, even psychologists, they think of perception to be a very low level process, which basically has to do with sensory signals. But this is an example where we spend so many minutes simply to show you that perceptual processing actually is a very complex problem solving task, where it has inputs from multiple parts of your brain, including memory, which comes from past knowledge. This is all memory, by the way. Past knowledge, previous hypotheses, prejudices, and many other things, including where you grow up, as somebody was saying, what you have read, what you can think about at that point in time, maybe some more abstract things about how your math is or how your graph is, and other kinds of all things put together, along with, of course, the sensory signals. So perception is not just sensory signals hitting your eyes. Perception is a whole lot. In fact, actually, if you if you look at the perception literature, it shows that if we would be imaging your brains at this time, a large part of our brains were involved in solving this perceptual problem. But actually, it's not just for a perceptual problem. It's a multidimensional problem, and hence it requires multiple inputs from multiple parts of your brain, and not just your eyes or the vision, as is commonly attributed to perception. And we also know there are some commonalities, because a lot of people arrive to similar understanding or similar representation or similar inference. But there's also a lot of individual differences, as came out from a lot of people who said why they chose B or C, and most of the times the answers were different. So this is the complexity of perceptual processing, and that's what I wanted you all to appreciate. Let's move on. So the other thing that happens in perception is, think of it as a light. So you can zoom in or you can zoom out. So that's why it's sometimes called focused perception or distributed perception, which is linked to a global or a local style of processing. And again, I'll skip all the theory part, but there's an example which is given by David Nevon. So Nevon was the first person who created these letters. That's why it has got the name as Nevon letters. And they are set at the global or local processing, because you are talking of different kinds of scope, zooming in and zooming out. So here what you see on the top side, the lower letter, or the hierarchically lower letter, is 8. So this is 6 made up of 8, 9 made up of 8, similarly H and S made up of 8. So you have letters, digits at the global level, which is 6, 9, H and S. The local level is constant at 8. These are hierarchical stimuli, as it's called, and they're sometimes also called Nevon letters. Nevon letters are hierarchical letters made up of letters or digits. This is local processing, where your global level is fixed, so all of them are fixed at 8, but locally they change. So here your local level is 6 and then 9 and H and S. So if you're doing this kind of processing, you're doing global processing because globally things are changing, locally they're constant. If you are doing this, then you are doing local processing because locally things are changing, globally things are constant. But both are hierarchical letters, and if perceptually you are attending to the global level, then it's called zoomed out or global processing. Or if you're attending perceptually at the local level, then it's zoomed in or local processing. This is a completely perceptual task, but it shows that perceptions or stimuli themselves are hierarchical in nature most of the time. Clear? Any question on this? No? Okay. The next thing is, well, again, let's see an example. So this is Sir William Hamilton, who is a great psychologist, who was a great psychologist. And he had a very, which you might think to be a very naive question, but actually it's a very deep and interesting question, which is how much capacity does my perceptual systems have? So he was interested in what he calls sensory memory, not he, I mean, people after him called sensory memory. The question is, how long does sensory memory last, or how much can I perceive in a small amount of time? And he used to do that with marbles himself. You know, this is not an experiment really, this is more about introspection, where he would throw down 10 marbles or 10 digits, and he will try to remember how many of these can I remember. So you do this task like, something like this, which is a digit span task. So the way to test that is you either you give yourself or your friend or an experimental subject different sets of letters. So here you have given 4 letters, you are given 5, and likewise you keep on increasing the number of letters. These are random letters, so you can't really easily remember them. And what you do is you keep on giving them, and the person's task is to respond after you, what did you show, and you check till what length this person is able to recall the same set of letters in the same sequence. That's very important. It's not like you recall the same set of letters only, you have to recall them in the same sequence. And wherever you stop, that is what your digit span is. So if you are able to do up till here, your digit span is 6. If you're able to do up till here, your digit span is 7. You, in the sense, whoever is doing the task, and likewise. The larger the digit span, the larger is your sensory memory. So the question what Dr. Sir Hamilton was asking is, how long do they last? So if I show you this, after how much time, if I tell you to recall, you will be able to do it? Is it immediately? Is it after 1 second, 2 second, 5 second, 10 second, likewise? That's one question. And second is how much. So both time and amount together says how much amount of information I'm able to store in my sensory memory. And how much is that is what Sir Hamilton was interested about. Okay, so what do you all think about this task? And any questions if you have, you can ask me quickly. Is this a good task to test working memory? There was no working memory that time. Your sensory memory, or it's not a great one?
Sir?
Very simple question. Is it good or bad as a task? Who is
Sir?
it? Yes, Akash.
Sir Akash. Sir, if the numbers were in a specific pattern, then remembering would have been different and rather than random
Sure.
numbers. So
Yeah.
it would affect our sensory memory's duration.
Right. So the point of having random number, or the reason to have random numbers, is deliberately to prevent you from learning a sequence or using a sequence. Because you are interested in the number of items or the number of digits. That is why they have made this task random. Okay. But is there any problem with this task? Have any of you tried it before? Yes, Kushagra? Kushagra, go ahead. Yeah.
Am I audible, sir?
And now you are.
Yes, sir. Sir, I'm asking, sir, like if we try to learn them like a single digit 7, 1, 5, 4, sir, it would be a bit difficult than if we try to learn them like 715, 485, 61, and 93. Sir, it would be a bit easier. So sir, what would be our digit span? Like अगर जो मतलब एक एक डिजिट करके याद कर रहे हैं तो मतलब 5 डिजिट याद हो रही है, लेकिन जब मतलब कम कम कंबाइन करके किया तो 10 की 10 हो गई, तो डिजिट स्पैन क्या होगा in that case?
Very good. So let's hear what Akash has to. Or did you have? Did anybody else have your hand up? Or should I answer the question? Okay. So a couple of people. Yes, Rachit.
Yes, sir. Sir, I have heard about this task that it helps that it tests the working memory, but also that since it tests the working memory, it tends to be very highly correlated to your intelligence. So if you can memorize large sequences very quickly, that's an indication of you having greater intelligence in general.
So yeah, let me answer. Let me talk about both of the points raised. So Kushagra, so what you say, there's a word for it in psychology and also um, in AI, because this has been used in modeling work also, which is called chunking. Chunk, CHUNK. So chunking essentially is exactly what you said. I can break this 10 into chunks of 3 or 2. So I can say 71, 54, 85, 61, 93. I can break it up in chunks of 3, which is 715, 485, 619, or even 4. This idea was not there when Sir Hamilton was asking this question, but later on people debated about how big the digit span is, exactly the way you have said. And now it's commonly understood that it depends on the number of chunks I can hold, not the number of individual items I can hold. So if and now we also know the number. Typically, it is about 4 to 5. So 4 to 5 chunks is what your sensory memory is able to hold. Nowadays, we talk of what Rachit was saying about working memory. We don't talk about other kinds of memory, but I will talk about it when we talk about memory in detail. But the essential idea is, yes, you are right that we can break random sequences into less number of sequences, and that act is known as chunking. And your digit span will be the number of chunks that you can hold in your sensory memory. Now, the second question or the second point about working memory. So remember that working memory does not mean, so if you have higher working memory, that does not mean you will have higher intelligence. What people have shown is it is correlated. So you might know from mathematics, correlation meaning does not mean it is caused. So you can have or you can show empirical evidences that somebody who is scoring high on a digit span per task also scores high in an intelligence task. That's the meaning of correlation. But to say that if I have a higher working memory, I will be more intelligent is to say there's a causal chain between me having higher working memory and higher intelligence. Now, some people have also argued that and shown some empirical evidence for that using, let's say, regression models where you can predict intelligence from working memory, and others have shown no, that's not true. So the scientific verdict is not very strong about the prediction part, but there seems to be a decent amount of correlation between working memory and other kinds of cognitive abilities, including intelligence. Of course, intelligence itself is a very tricky word. People have argued multiple things around it, the ways to measure it, the kinds of intelligences you have, what does it mean, and many other kinds of stuff. But even without going there, it does seem now, to cut the story short, of about 50 years of research, that working memory is a very, very important component that does come in handy for a lot of things that we learn or we do or we implement in life. So having a larger capacity in working memory does help. And there are multiple implication policy issues around it also. Does that mean that whatever we are measuring is based on memory? Whatever exams measuring are based on memory. So those kinds of debates are there, which it's hard to take within the class, but it does seem that working memory is a very important component of thinking. That much is for sure. And this is a measure of working memory. But here they didn't really talk of working memory, because working memory is a much more complicated concept. Sensory memory is something that your senses can hold. So it's not working memory per se, because it just fades away too soon. So yes, in the chat, how much important time is a lot. Sensory memory is supposed to be something which is going to be stored for a small amount of time. If something is being stored for minutes, then it's not sensory memory, because you are fed with senses all through the day in a large amount. So you can't really have um, the buffer to store many things in your sensory memory, because once one thing comes, immediately your senses take in some other thing. So imagine the number of sentences I said in this lecture. There's so many. How can you remember that? How can you even perceive it? You will perhaps only be able to store 1 or 2 or 3 words. You might be maximally storing one sentence. Sometimes we don't even store a sentence. We store just a part of our sentence in our sensory memory, because they are just coming and coming and coming one after another. We don't have space. All right. So that's why the time part is indeed very important, and the time for sensory memory is a very short time. All right. Akash, yeah. Kushagra, do you have anything else to add? And we can hear what Akash has to say. Sorry. Yes, Kushagra, do you have anything else to add? Or this is your hand up from the previous time? Then Akash, yeah, go ahead. What do you want to say?
Sir, I had two doubts regarding this test.
Mm-hmm.
Sir, first, suppose a person could memorize up to 6 digits only, and suppose after he couldn't memorize 6 digits, then for 6 to 10 times more, he's again and again shown the a combination of 6 digits only. Sir, will repetition enhance his sensory memory or not? Will it be effective or not? I want to ask this.
Yes, repetition always helps memory. So whenever whenever you have repetition, it does increases the chances of you either remembering it or even memorizing it. Because people get better at the task itself. Remember that it's not, practice effects are not independent of what you're studying. Right? So if I am bad at something, and that is also an example of adaptive tests that are now a part of many education systems, that if you are able to perfect yourself at one level, only then you go to the next level, right? So if you are able to repeat and repeat and repeat and get better at 6, then it is true that you will get better at 6. And if you are, then you are not really testing, or you can't conclude that you have that as the span as it is, because you have had more number of occurrences at level 6. But yes, if you do have more number of occurrences for level 6, you will get better at it. However, that is not going to happen in perpetuity, because let's say you're talking of level, a 7 or 8 or 10 or 12 or let's say 20 letters. Now, at some point, there will be a hard stop, or at least some kind of a decent stop, where you won't get better any further. So maybe even if you keep repeating a set of 25 digits many number of times, you will just not perform above chance, which means that you are not learning how to tackle 25 digits in your sensory memory. So both are true. It is true that repetition does increase our chances of learning. However, it is bound by a kind of cognitive constraints or limitations that our system has. It's not going to happen forever. All right, that's one question.
Yes.
Is what's the other one?
Yes. Sir, and suppose in place of digits, we have combination of digits and letters. Then also there are means someone can memorize up to 7 digits. So will he be able to memorize the combination of letters and alphabets also up to 7 digits, 7 bits? Will it
Yeah.
be same or difference will be there?
Uh, it's hard to say really, but it depends on many other things, including how much is the percentage or proportion of letters versus digits, whether it's a unique stimuli or whether it's a commonly occurring one. But in general, if you mix stimuli, if you mix digits and letters, you might just become worse because there will be more interaction. Okay, so yes, Ayush, it says it sounds like RAM of our brains. I mean, it's not a joke. There are people actually who have metaphorically said this is indeed like RAM. In fact, there's a whole computational theory of mind where they treat these kinds of um, memories, like sensory memory, or even like short-term memory. The anecdotal evidence or the simile is RAM, whereas whatever you stored in long-term memory is like hard drive or something, and whatever you is more hardwired to do is more like ROM. So yeah, the people are using those kinds of metaphors, not similes, metaphors. So this is one experiment which is famously talked about, where this is a chimpanzee, and you show the digits at different locations of the screen, and the digits are of a certain sequence. So you will have 1 and 2 and 3. So they don't come in randomly. They come in a specific ascending or descending order. And the task of the chimpanzee is to point out on the screen where in the screen it occurred and also the order in which it occurred. So he has to first point out to 1 and then to 2 and then to 3. I mean the space. Okay, so this is taken to be an evidence that working memory or working memory capacity is important across species. It is also taken to be evidence that working memory is a core part of our brain that has evolved over multiple generations and even multiple evolutionary chains of phenotype. And hence, it's extremely important to study working memory. And working memory is something, for those who want to predict things from working memory, as I was saying, that is the truth of that, or the science of that is actually applicable not just to humans, but also to non-humans. So that makes working memory really kind of a hot thing to do. All right, so let me now take you to a different kind of a ball game. And this is very, very interesting. So listen to me with attention. So this is a gold plate. This is a gold plate stuck to Voyager spaceship or spacecraft that was sent to outer space by NASA. And the project in that, or the main engineer in that project's goal was to have different forms etched on this edge, etched on this gold plate to represent different concepts from Earth. Okay, there are multiple reasons why I find this as fascinating when I think about cognition or psychology or perception and the overlap between psychological sciences and pure sciences, or even now space sciences. So where do you think the really cool stuff or the really interesting thing about this project comes about from? That's the easier question I will first pose. What's really exciting about this thing? If say, for example, tomorrow you are an engineer who have to do this, what is exciting about this whole thing? There are hundreds of things which are exciting, but something that occurs to you right now. Yes, Nishant.
So I think that this assumes that if there is a civilization out there who finds this, then they might also have gone through the same evolution in science as we have done. So they might also have explored the similar concepts, and so they can learn from it at what stage we are.
Yeah, that's a huge assumption, isn't it, that people are making? It's humongous, assumption wise. You're right. I mean, but if we at all have that kind of an alien species, we are also assuming certain things about ourselves and certain things about them when it comes to perceiving forms or perceiving shapes, because we are talking about perception. What are those?
Sir, we assume that they are intelligent species that would be able to communicate or maybe perceive the things uh, we can perceive. Like maybe we are assuming that they see the world the same way we see it.
Absolutely. And um, what are the prerequisites for them to see the world the way we see it? Perception wise, let's say, forget everything else, higher order. Just simple form perception. A square is a square for both of us as earthlings and them as aliens. What are the prerequisites for that to happen? Things from what we covered, like today and in the previous lecture. Not asking anything outside that.
Sir, they need to have eyes also.
Yes,
Yes,
but
sir.
just by
And
eyes you can't.
their brain should be able to perceive a square as a square, like from our eyes to our brain. That process should be similar. We are assuming that,
But do we
which
need
might be
them?
different.
Yeah, do we
Like,
need them to have brains?
like we are assuming that they are intelligent species. So
They
yeah.
are intelligent, but do we also have to assume that they are biological?
वो मान रहे हैं भाई हमने कुछ नहीं बोला वो मान रहे हैं वो तो आशिक का आगे सुगने लग गया था
Kavish, you have to mute yourself, please. Thank you. Yeah, so I was asking, do we have to assume that they will have biological brains to perceive a form as a square? Think about computer vision.
So maybe not brain as such, but they will need to have something which uh, is similar to it.
That's true. But do they need a language?
No, they might not need the language. Like even on Earth, different species have different ways of perceiving things and communicating. So they might not need language as such.
Right. So, I mean, this also shows how perception is kind of more fundamental than anything else. So I love this project because this says it right in front of your eyes, how perception is something that is so fundamental that we assume even aliens would have it. And this is no joke, right? This is like a multi-billion-dollar project. So automatically, whatever engineers and our project designers and managers are deciding, a lot of thought must have gone into it. And after that, what they came out with is figuring out that maybe it's just visual form perception that is a way to communicate things about Earth. I mean, if you think about it, it's just a huge thing. And which I will not do in today's class because it requires some more time, and I don't want to rush through it. There are other couple of things that are extremely pertinent about visual perception about ourselves that is relevant from this project. Could anybody point those out? What are the things that is relevant or we understand about ourselves, about Earthlings, that might have gone into, designing these are etches, okay? These are etched on a gold plate, essentially. So what understandings of perception might have gone into it? So if, for example, what's the whole input from psychology, for example, that can go into this large space exploration project? They had a lot of psychologists in their team, by the way. NASA has a lot of psychologists. What could those be? I mean, I know that you are just starting out, but still, I'm sure you have good ideas or thoughts.
Sir, in this project, the scientists and many officials sent music into space for aliens. They must have thought, due to the psychological perception of view, that even if somebody is not able to understand the language, every person in this world can understand the feelings of music. So if the perception of aliens is similar to that of ours, so they could be able to understand the feelings of music that are ingrained into it if they know how to play it.
Yeah. Music, by the way, is also a kind of form. It's a kind of auditory form. We are, of course, talking about the visual perception here, but music also is an auditory form. In fact, there is research which shows that specific kinds of beats um, captured the same emotion across cultures. So, fast beats versus slow beats, or different. They have also worked with classical Indian ragas, the starting part of the raga and the ending part of the raga, which is where the major emotion is. I mean, if any of you are into classical music, or at least have seen movies or web series which are around classical music, you might know that different ragas are sung at different points in time to communicate different kinds of emotions. And so people wanted to try out, let's say, well, you have this raga in India. How does a person in Iceland figure out what I'm communicating emotionally about it? And it turns out that people can actually decode the music, decode the emotion from the music, irrespective of culture. So there is really no cultural. I mean, I also hear a lot of in psychology, everything is contextual, everything is cultural, everything is individual difference, everything is subjective. It's not true. We have enough evidences of universality across humans. And now, of course, we are talking of this, of course, is a long shot, but we are still trying to think of similarities in perception across planets or across galaxies also, right? Yeah, but let's come back to visual, and here in the picture itself I have this form which shows multiple visual forms. So what does that say about human visual perception among the couple of things that we have been talking about, which you see here? Certain principles or um, certain ways we use our memory to understand something. Can everybody say what this is? First of all, let's try that. What is this? What does this represent?
So that part is supposed to represent our sun and the cycle of suns.
No, what do you think this
Racetrack.
object is?
Racetrack.
Okay.
So the
Everybody
large,
else thinks it's the
large
same?
hadron collider, the particle physics thing.
Sorry, I didn't get that.
The large hadron collider, which shows our advancement in science, I guess.
Yeah. Okay. Anything else that it can represent? Does anybody watch Young Sheldon?
Yes, sir.
Okay,
Yes, sir.
so so what would Sheldon say out of this? Can't this be like a toy train? What he calls the Shuwu train?
Something related to neutrino.
Probably. So see, what I'm trying to point out is it's not quite clear, and this happened for the heart example also. It's happening for which you might think to be a simple thing, but this, of course, is serious business. But here in Earth, in our class, we have three representations or three meanings of the same form that we are perceiving here. So even if you do this experiment on Earth and you say, well, I have represented different kinds of things about Earth, can you tell me what this is? We are finding differences. However, we did not find, or we do not find differences to say that this is a circle. So this is where you have, individual differences and universality in the same picture. Okay, so let's try one more. What is this thing?
Some sort of beats of a sound.
Sound.
Some waves kind of thing.
Graphical representation.
Sorry, what was that?
It can be the view of a spring, like front view of the spring.
Mm-hmm. It can be a graph, it can be a seismological instrument, anything. But what is, and this is the difference, but what remains constant is there is something fluctuating that we are seeing, which we can measure, or which we can, implement or engineer, which are wave-like. So this is another such similar example of course, communicating, um, you know, scientific development on Earth, but also assuming that there is some kind of generalizability for this stimuli. This probably is this. Okay, what is this? Let's try.
That is the sun's location with respect to other heavenly objects.
Atomic bombardment.
15 neighboring stars that are that are the closest to our sun. Their position with respect to our stars, our suns.
Okay, so there are also certain things like this, which seems to be less contested. So, most people, at least most people like you all, might say this is a sun. But if we show this picture to, let's say, some homeless street children right in front of IIT Delhi, do you think people will say it's sun?
Star. A shining star in the sky.
Still, it's somewhat related to star or sun. So this is what I was trying to say. It's not the case that what we try to assume about ourselves is completely well defined, but it is also not the case that everything is subjective. That's why we do have similar amounts of forms that we can perceive about ourselves. The only additional, not only, I think the big additional step that goes into this project is we think at least some of what we are communicating will be understood and understood in the same way, if nothing else. Is there some additional stuff about, let's say, perception that these guys, whoever these guys are, can understand about ourselves, if not understanding what we are wanting to communicate? So imagine we want to communicate this as distance from the sun, but they don't understand this as distance from the sun, but they just perceive it as a form. Will still that help us in some form of communication across planets? And again, what does that say about our form perception? Or let me use a more simpler example. So this is another example from the same disk, which you see here, and this is self-explanatory. Perhaps most Earthlings will have similar or related interpretation or meaning or semantics of this picture. There is lots I have to say about the picture, so I will store it for the next class. But is it possible that there would be differences in what you perceive as Earthlings? I mean, Earthlings in the sense all of us on Earth when we look at this picture, or this is going to be almost similar across all people on Earth, or most people on Earth. Meaning wise, I mean, not the exact act.
So one issue that I think is noticeable is that we the people on Earth know what other people on Earth look like, so we can make out that these two figures are of other humans, and so we can guess that that is something that the person is trying to attack or something. But an alien species, someone who doesn't know what humans look like, might not be able to guess or figure out what this means.
Yeah. So what I will do is I will post this as a short activity in the next class, or rather before the next class. The task will also be well defined, what it has to do, but I'm just telling it here and I'll close. Is the task is to figure out what all assumptions are we making about perception in aliens when we are communicating this picture? And please pay attention to all of these things. The forms, numbers, measurements, acts, interpretation, meaning, the visual perceptual system, brains, eyes, higher order brains, whether they are biological or not, everything that you can think about. Is this clear?
Yes, sir.
Okay, great. So I will post it, and from now on, whatever we do, we have not started, but whatever we'll do it on Moodle. The link will go from one of the TAs, and your answers will be on Moodle itself. All right, and then we'll start off from where we leave, of course, in every class. But in case you have questions, again, some of you have mailed me. I have not been able to reply to that. I'm sorry, but we will keep the first few minutes to answer questions from the previous class. So please keep your questions also handy so that you can use that time. Okay, so I'll stop here for now. Stop the recording, and y'all can leave. So thanks.